Hey, welcome back. Today we're going to continue our Desmos course here, and I'm going to go over solving systems at intersections. So this entire video will be dealing with systems, right? Which are, again, if you've taken the SAT, it's a really common concept that's tested, right? So, you know, SAT systems can contain like awkward coefficients, right? Uh, they can have equations in different forms, or they can have like different types of functions that, and then you want to find an intersection of those, right? The thing about Desmos is that it just graphs all of that for you, and every intersection is a point that makes the system of equations valid, right? Or that makes each equation true in the system, right? So the standard approach to using systems on the SAT for Desmos is you just graph both of the equations onto the onto the left side here. So for example, let's say I have 2x plus 3y, and let's say that's equal to 13, right? So of course you can see that there's a line produced here. Nothing too special. But now let's say you have a different equation, 5x minus y, say it's equal to 7. Well, now, right, if you're trying to find the system of this, or trying to find the intersection of these two lines or these two equations, well, you can just obviously see that they both intersect at this point here, right? Tap on the point. That point here is 2 comma 3. So what that means is that an x value of 2 and a y value of 3 both if you plug it into either one of these equations, it holds true, right? So for the first one here, 2 times 2 is 4, plus 3 times 3, 9. So 4 plus 9 is 13. And likewise, you can also check for blue, and you'll see that 10 minus 3 is also equal to 7. So once again, this is like the standard approach. You enter both equations as written, and then Desmos just gives you the point of intersection, right? Now, when should you actually use Desmos for these types of questions? Um, you should begin with Desmos when the two equations involve the same two unknowns. What I mean by that is that there's only an x and y variable. There isn't like an x and y and a y and z, right? So you should only use Desmos when you have two equations where you have the same two unknowns. Also, you should use it when the equations would take several algebra steps to solve, right? Like if it would take a long time to solve manually, that's when you use Desmos, right? And just to kind of know when that happens, it's when you use fractions, when you have these weird fractions or decimals as your coefficients, right? You should use Desmos when one of your equations is a linear and the other one is non-linear. So like one is linear and the other is curved, right? It just again, it just does everything for you, makes it so much simpler. You should use Desmos when the graphs intersect more than once, right? Because sometimes you don't only have one intersection point, but you can have two intersection points or more, right? So that's another case. And finally, right, if the SAT question asks you for x comma y, like an ordered pair answer, or an expression, you can use Desmos because you can already find what those x and y are, right, and then go on from there. The only time when you would not use Desmos for these types of questions is when you can right away, like immediately, use substitution or elimination, right? So, for example, if I had like x plus y equals 10, try not to look at the graph here because that's what I'm trying to prove. X plus y equals 10 and x minus y equals 4. You don't really need to use Desmos for this, right? If you just add these two equations, you get 2x equals 14, and then that gives you x equals 7, right? And then you can plug that back in and you get y equals 3. So then your point of intersection is going to be 7 comma 3, right? And of course, as you can see, that is the point here in the diagram 7 comma 3. So anytime you can just right away use substitution, please don't use Desmos, right? Um, Now that's kind of covering the very basics in the standard approach, right? Now let's kind of talk about reading the problem itself and what it's asking. So for example, some problems might just tell you to find the solution x comma y. In this case, that would be 7 comma 3. But you gotta be careful because sometimes they only care about the value of x or they only care about the value of y. So you would correspondingly put 7 or 3 for your answers, right? Uh, Sometimes, right, they actually also ask you for the sum of the x and y coordinates. So it would be like x plus y. In this case, that would be 10. Or they could give you some weird random expression like, find 3x squared minus 2y cubed, plus who knows what, right? Like you can just go if you have the x and y coordinates in mind, you could just plug that into Desmos and just plug in the x and y, right? It's not that hard. So yeah, that's again another use case of Desmos. Um, the next thing is like, let's say you're given a graph of y equals 2x plus 3, and you're given a graph of y equals x minus 2 squared plus 4, right? So you're given those two graphs, um, right? And you can see here that they intersect at 2 points, right? Like I said earlier, there are some times when these systems might intersect at 2 points, and this is one of those cases, right? Usually happens when you have like a quadratic and a linear function, but it could also be many other things. Um, so these intersect at 2 points. But let's say the question is only asking you to find, let's say it's asking you for the solution x comma y with x greater than 3, what is the value of y? Well, if you're trying to find the value of y when x is greater than 3, there's only 2 points that the system intersects at, and those are with x values 1 and x value 5, right? X equals 1, x equals 5. Well, you're trying to find the value of y when x is greater than 3, right? So you don't even look at this 1 comma 5 here. That's not the right point. You look at 5 comma 13, and obviously the y coordinate of that point is 13. So that's kind of another use case, right? Sometimes they give you like a condition in the problem when you have multiple intersections, and you just got to figure out what they're really asking for looking at the graph. Um, so yeah, that's again a kind of another example. Sometimes, right, you're of course given SAT word problems where um they describe two conditions involving the same two quantities, and you have to define one variable for each quantity and then just write a system. So what is an example of this? Well, let's say you have a rectangle with a perimeter of 50 units, right? Well, let's call x let's call x the length and w, or sorry, x the length and y the width, right? Because we can't remember, right? From the previous videos, you can't actually put the letter L here because Desmos doesn't accept that. So if x is the length and y is the width, right? How can we make an equation for the perimeter of a rectangle? Well, you know that a rectangle has um perimeter of the length plus the length plus the width, right? It's length, length, width, width. If you add those two together, you get 2 times the length plus 2 times the width. So in our case, that would be 2x plus 2y equals 50, right? So that's one of the equations. Now let's say they also tell you that the length is 7 units greater than the width. If the length is 7 units greater than the width, that means whatever L is, I'm going to use L here for a sec. I know it doesn't register, well, that means that the length equals 7 units plus the width, right? So then you have the width and then you add 7, right? So you have the width and then you add 7, right? So that's kind of the thing here. For some reason it's pointing a line, I don't know why, but I wouldn't use LMW. I would say x equals y plus 7. And of course, when you do that, you get a system here, and you'll see that the system here intersects at 16, comma 9. So that means the rectangle is 16 units long and 9 units wide. So that's kind of a way to set up systems in the word problem and just plug it into Desmos. It literally gives a solution for you, once again, to our convenience. Um, and that's really it, right? That's all the kind of things you really need to know for these basic or intermediate level system questions, right? I hope this video helped. If it didn't, please leave any questions you have down in the comments, but stay tuned for the next lesson of this course. Thank you.